So I welcome you once again into the online classes, and this will be the video mode of enrichment class as we have been doing. But we are certainly at the same point of time we are discussing in live classrooms also via Zoom app. So I hope we will interact very soon. So today's topic, which I have chosen because we have been discussing solid state and solution, and we have just started electrochemistry. But I have chosen such a topic which is a very small one. It is thermochemistry. Reason behind choosing this topic, it is a small topic. In class 11 enrichment class, we have not discussed about this topic at all. So meanwhile, when we are discussing electrochemistry, so it will take some amount of time, at least 2-3 classes at least, to generate few concepts. Then only we can go for the enrichment classes of electrochemistry, because CBSE curriculum and this jEE mains and NEET coaching are going side by side. You need to have a little bit of understanding of electrochemistry. Then only we can propagate up to the problems of the hurdle level. So meanwhile, I have just chosen a topic which I think all of you will be finding easy to deal with. That is thermochemistry. I have not discussed this topic in enrichment classes in class 11, but the topic is known, of course. So without further wasting time, let us start discussing the problems. As the problems will come, we can discuss the related theory also whenever it is required. So the first question of this goes like this. First question is, in the reaction Y rather than Z, Y converts to Z, delta H is given as plus 100 kilocalorie per mole, and for the reaction Z goes to X, delta H is given as minus 80 kilocalorie per mole. Here, these two informations are given, and the question is, rank the enthalpies. Rank the enthalpies of formation of X, Y, and Z in increasing order. So there are various options given. I am not writing it down, or if I write it down, it will be like this: Y, X, Z. Option B is Y, Z, X. Option C is X, Z, then Y, and option D is X, Y, Z. Now, to deal with that, we have got to understand what does this change of enthalpy value suggest. It is, you can say, the enthalpy changes, that values are given. From there, how can we rank the enthalpies of formation of X, Y, and Z individually in increasing order? So to do that, we have to understand first that if certain enthalpy values are given, what does it mean? So let me do that. Suppose, so I'm erasing the options, just keeping the question because I will be solving here only. According to the question, here it is given, as you can see here, if Y converts to Z, delta H is plus 100, right, kilocalorie. So what does it mean? This one, that is delta H of standard enthalpy of Z minus standard enthalpy of formation of Y should be 100 kilocalories, right? Again, according to this, we can also say that delta H of formation of Z is greater than delta H of formation of Y. So if it is so, according to this, because the delta H of formation of Z is clearly greater than the delta H of formation of Y according to this. So I have got the increasing order between Z and Y at least. Now let us talk about the order when these values are given. So it is given Z is converting into X and delta H is given as minus 80. I am not writing kilocalorie and all. According to the laws of thermochemistry, we know that if the forward direction it is minus 80, so in the backward direction means the opposite way, delta H should be plus 80. So according to this logic, delta H of formation of X minus delta H of formation of Y, not Y, it is X and it is Z, should be 80 kilocalorie per mole. So who is greater? Obviously this one is greater. So delta H of formation of X is greater than delta H of formation of Z. So from here it is very clear that X is greater than Z and Z is greater than Y. So it should be X greater than Z greater than Y. This should be the ideal order. And as per the given options, I think option C, which I have written already, is correct. So it's a very simple thing. Just minus 80, I have just turned it around. It becomes plus 80 when the reaction is reversed. Accordingly, I have written down. Accordingly, I am getting the answer. So you note it down carefully. The next one for today, the question goes like this. If enthalpies of formation of C2H4 CO2 and H2O at 250 degrees Celsius and 1 atmospheric pressure be 52 minus 394 and minus 286 kilojoule per mole respectively, the enthalpy of combustion, of C2H4 will be, what options are given? I'm just writing the options on the extreme right hand side, that will be best. Option is 1412 kilojoule per mole. Option B is minus 1412 kilojoule per mole. Option C is 141.2 kilojoule per mole. and option D is minus 141.2 kilojoule per mole. Anyway, forget about the option. Let us talk about the answer. The thing is, the question is the enthalpy of formation of C2H4, CO2 and H2O. These three are given at 250 degrees Celsius and 1 atmospheric pressure. The enthalpy of combustion of C2H4 will be, that is the main thing. That is what we have to calculate. Now the point is, first of all, without looking at the further part of the video, I request the students to stop the video here only and try to solve first. If you can go up to a certain extent or you can solve it, that is the best thing. If you cannot, first of all you pause the video here, give it a try, and if you cannot, then only look for the further section of the video. Be honest to yourself. Now see to it. We know that the combustion reaction of C2H4 means C2H4 reacts with oxygen, right? And it gives rise to the formation of what? Carbon dioxide and water. If it is so, the point is, if the reaction of both of these gives rise to carbon dioxide and water, first of all we need to balance it out. So here you can see C2, so it should be 2. If it is 2, then accordingly it should be 3O2, means we have to maintain, see the number of hydrogen once again, 4. So I have to make it 2. So 2 into 2, 4. 2 carbon, 2 carbon. Now see what are the things that is being changed. 2 oxygen, 4 oxygen. So it has to be 3 oxygen. So this is the balanced equation. Now delta H of the reaction should be is equal to the heat of the formation of the products, that is 2 into delta H F of CO2 plus 2 into heat of the formation of water minus minus, here it is C2H4, that is delta H of formation of C2H4 plus 3 into delta H of formation of O2. So this is the whole scenario. I think the values are given. Here it is 2 into minus 394 because it is given in the serial order, first, second, third. So it is the first, second and third. So CO2 is the second one. So CO2 will be minus 394. Then heat of the formation of water. Water I think is the third one. So it should be minus 286. So it should be plus 2 into 286. Value is in minus. And it is minus of, here it is C2H4. Question is, enthalpy of combustion of C2H4 will be how much? So for C2H4 it is 52, which is given already. So it should be minus of 1 into 52 plus this one, heat of the formation of oxygen. So as you know, in this case, in this particular problem, the value of oxygen should be 0. So we put it 0. Now you should calculate. Calculate and tell me how much it is, how much you are getting. If you calculate this, ultimately we are going to get an answer of minus 1412 kilojoule. So that will be the final answer. Remember, in standard state, for the formation of oxygen, the value should be 0, and accordingly the rest of the values are kept in, and accordingly it is calculated. Next question. Question is, heat of formation for CO2, carbon monoxide and H2O are, I'm just writing it down one by one, okay? For this one it is given 393.5 minus 393.5, and for this one it is given minus 110.5, and for this one it is given minus 241.8. In all these are in kilojoule per mole. So these values are given. We have to calculate the standard enthalpy change in kilojoule per mole, of course, for this reaction. So very common type of problem, and this type of problem you have to face. So let us see how we can deal with it. So in order to solve, we can see the values are already given. So first of all, let us write down the formation of these three. How can we write down? Carbon plus oxygen gives rise to carbon dioxide. Now for carbon monoxide, it should be half oxygen, I think. It should give rise to carbon monoxide. And for water, what should be the case? H2 plus half O2 should be H2O. So these are the things which are written. Everything is gas actually. Now here it is, heat of formation is minus 393.5. Suppose 1 we can write, or simply delta H01, delta H02 we can write. It is minus 110.5. It is delta H03, which is minus 241.8. Here it is, all these values are in kilojoule per mole. And this is equation number 1, this is equation number 2, and this is equation number 3. If we have to calculate the standard enthalpy change, now one thing here it is to be mentioned, which I have not written in the question, because till now you can still pause the video and can solve the question. Calculate the standard enthalpy change for what? For this reaction. The reaction is CO2 plus H2 giving rise to CO plus H2O. For this reaction we have to calculate. So let us see the possibilities. Okay, how to solve it, means what should be the way out. We have to see, carefully listen, we have to see there are three reactions. By permutation or combination, by addition or subtraction of these three reactions, we have to ultimately get this. That should be the target. So stop the video here, try to add or subtract these three and try to get this one. Whether you can do it or not, that you check by yourself. Now, if you can, that is the best thing to do. Let us see how it can be done. On the right hand side, what are the products? Carbon monoxide and water. There is carbon monoxide and there is water, so it should be on the right hand side, of course. So it gives me the idea that 2 plus 3 probably should be done. So if I do 2 plus 3, carefully see, carbon monoxide plus water I will get. Okay. But on the right hand side there is carbon dioxide. But over here in the actual equation it is on the left hand side. So in order to keep it on the left hand side, I have to subtract this equation from the addition of these two. Is it clear? These two I want to keep it on the right hand side. So I will add these two will be on the left hand side, these two will be on the right hand side. Fine. So I'm just adding 2 plus 3. You see carefully. If I am adding 2 plus 3, it becomes like this. So it will be C plus H2 plus half and half means oxygen gives rise to carbon monoxide plus water. Okay. After this, on the actual equation, H2 is there, but carbon plus oxygen I don't need. I need carbon dioxide. See here, interestingly, carbon plus oxygen is on the left hand side. So if I can subtract this to that, if this is the equation number 4, and if I subtract 4 minus 1, I think I will get the desired case. So just for a moment, I'm just erasing this part. I hope you can see the actual equation. What we can do is, I'm rewriting the equation number 4, that is C plus H2 plus O2 giving rise to CO plus H2O. If I subtract this, so doing 4 minus 1, it becomes CO giving rise to carbon plus half oxygen. Okay, see it now. This will cancel out. This is not half, this is only oxygen. This will also cancel out. So it remains on the left hand side CO plus H2, which is fine, giving rise to CO plus H2O. So I am getting my desired equation. The point is, by which process? What have I done? I have done 2 plus 3, right? Then I have subtracted, which is equation number 4. 2 plus 3 if I do, I will get this. So 2 plus 3 minus 1, that is the trick. So according to that, the delta HF total should be delta HF of equation number 2 plus delta H3 minus delta H1. And as per the given cases, although I have erased, but you can see it from your video, it should be 2 means minus 110.5 plus minus of 241.8 minus of minus 393.5. So after calculating all these things, you will be getting 41.2 kilojoule per mole. Because see, you are getting 393 around, and here it is 241 in minus, here it is 110, so it is 252 around, and here it is 393, so this should be the answer. Here you can check by yourself. It is plus 393.5, and here it is 110 and 241, so you will be getting probably 8 plus 5, 13, so here it is 2 and here it is 352.3, so it becomes 0.214. So that is the answer. This one. So this is how it is to be calculated. I hope it is clear, and similar problems you are supposed to solve.